Hello, my name is Willow, and in the scenario put forth below, the U.S. is currently in its 480th day of self-quarantine, and some crazy crimes have been occurring related to the coronavirus pandemic. I'll be discussing a crime that took place this past Thursday night. A woman named Lisa was unloading her groceries from her car when she was struck from behind, and when she awoke, she found all the toilet paper she had just bought was gone. She called the police and filed a report. At the crime scene, they found a hair, which they collected as evidence. The likely suspects were rounded up, which consisted of Lisa's neighbors. Below, we see the two VNTR loci that were run on separate gels to create DNA fingerprints that we can now analyze to hopefully find the perpetrator. The victim below is Lisa. The evidence is the hair sample collected. Suspect 1 is Judy, who is a mom in the neighborhood who has never been very friendly towards Lisa. Suspect 2 is Judy's teenage son, Sam, who the police think may have been in cahoots with his mother. Suspect 3 is Tom, who lives alone and keeps very much to himself. And finally, Suspect 4 is Sarah, who is quite friendly and has interacted with Lisa many times. It is now our job to examine the evidence and determine who could be behind the attack. Each of the bars in the loci represent alleles, and each DNA sample has 2 alleles. For a person to be confirmed as leaving this piece of evidence at the scene, they must perfectly match the 2 alleles of the evidence sample in both loci. We will look at locus 1 and start with the victim and go down the line. If we look at the 2 alleles in the victim sample, we see that neither match with the evidence, so they can be eliminated. If we look at suspect 1, we see that each of their alleles perfectly match with the evidence, so they are still a suspect. If we look at suspect 2, we see that one of the alleles match with the evidence, but the other does not, so they are eliminated. If we look at suspect 3, we see that neither of the alleles match the evidence, so they are eliminated. And finally, we look at suspect 4, and we see that both alleles perfectly match the evidence, so they remain a suspect. When we now look at locus 2, we can cross out the people that we eliminated above. We look at suspect 1, and we see that neither of their alleles match up to the evidence, so they can now be eliminated. And finally, we look at suspect 4, and we see that each of their alleles perfectly match the evidence. So based off these 2 loci, the police can conclude that Sarah was the one who left this piece of evidence at the scene and increases her likelihood of being the attacker. Although this is not pertinent to the case, we can also see how Judy is a biological parent to Sam by looking at these fingerprints. When we look at locus 1, we see that Judy and Sam share one allele here, and in the second locus, they share an allele here. When looking at parental relations in DNA samples, a child must receive one allele from the mother and one from the father. Given that they each share one allele in each locus, it can be hypothesized that Sam received these 2 alleles from his mother and these 2 from his father. So if we compared Sam and Judy's DNA at more loci points, they would always share one allele pair since she is the biological parent to Sam. I hope you enjoyed this example, and now hopefully you understand the concept of fingerprinting better and it's important in the field of forensics.